Caber's been quite a journey for me. So I wanted to share with you some of the capabilities that we've been able to develop. Um, First, just a brief background on myself. I've been in the IT space, places like Cisco, Akamai, Riverbed over the last 30 years or so in the Valley. So spent a lot of time in networking and security. One of the things, the last company I was with was a company in the SASE space. And I started looking at how applications are evolving and how we can secure them. And this is a result of answering some of those questions. So first thing I want to just mention, just a level set here. When we're talking about permissions and access controls on data, one of the fundamental things that we're trying to do is to keep Alice's data from Bob or your data from your competitors. And oftentimes the goals of protecting the confidentiality, availability, and integrity of data get lost in words like sensitive data and privacy and PII and PHI. All of those things are very important, but at the fundamental aspect of permissions and access control is if it's your data, you want to be able to control who has access to it. So proceeding with that idea in mind, that it's really permissions that are the most important thing in terms of building applications that are using either customer data or your data or employee data is permissions. We need to do this from a trust perspective, from a compliance perspective, obviously from a security perspective, if there's attackers that are trying to get at this data as well, and privacy. And if there's any better underscore to the fact that this is important, you can look at Glean's $4 billion valuation now, and the number one thing that they talk about is how important permissions are in terms of enterprise use of generative AI applications. So if you want to think about what I'm doing, what Caber's doing in very high level, we're giving every generative AI application the ability to put permissions on the data that's being used. One of the fundamentals of security is it needs to be deterministic. Authorization needs to be deterministic. We can't guess if it's your data. We can't use probabilistic techniques to figure out whether or not we should give access to somebody, because then we're going to be in with some non-zero probability actually giving people access to data that they shouldn't have. And so one of the I guess eye openers you could say is putting a permissions boundary that's deterministic around Gen AI, given that it is completely probabilistic in nature, is very important. So, and I know James talked about this in the beginning, the partitioning and multi-tenancy, and I think that there's a lot of great features and functionality that you can get in systems like Milvus and other vector databases and other databases, which are great for separation of customers, multi-tenancy in particular. One of the places where I've seen it fall down is when you start looking at it from a user access control perspective. This is where we ran into some troubles back at the last company I was with. I was building a SASE solution, providing user access to internal enterprise applications. Just because of the number of different variations on what these permissions need to look like. You're all familiar with terms like RBAC and ABAC, attribute-based access control. And now there's relationship-based access control, REBAC and such. The number of different ways that enterprises want to be able to provide access control is complex. It introduces a lot of complexity just in terms of not just whether you're trying to provide a user access to an application or user access to the data, but also from a support perspective or from an administrator perspective, you have to take multiple different constituents into account when you do this. So how can we do all of that in a vector database? It becomes very difficult. So, well, difficult, but a small matter of programming, right? If you wanted to put it that way. But dynamic privileges versus static permissions doesn't seem to work too well. This is just a screenshot from this company, permit.io, that's doing reback access controls, where there's a complex path that they need to go through in terms of providing a doctor who may be visiting with you in the exam room, needing to pull up some data in the moment and then be able to provide a prescription or something like that. And it's only during the session that he's with you in the exam room that he has access to this data, which is a pretty complex way of trying to formulate an access control to a specific chunk of data. So that's one of the key issues, one of the problems that companies face when they're trying to build access controls on top of GenAI applications. The other one is that it's actually not the user that's accessing the data in the vector database, right? It's the agents that are acting on behalf of the users, doing the queries into the vector database to retrieve information that's coming out. So this ends up being just a small matter of security because, well, you can't authorize the agent access to a user's data without giving that agent very broad permissions to access all of the data that may be in a system. Now, one way you can think about it is you could have the agents spoof the identity of the user. Let's just borrow their credentials, we'll borrow their group IDs and access roles and such. But this ends up being a big loophole in terms of security, because now you've given the agents the ability to do pretty much anything that the user is able to do. And if that agent ever gets attacked or compromised, then there's almost no limit to what an attacker could do in this situation. Now, certainly you can build in all sorts of protections, but then this becomes a very, very complex path to go down. So the third problem, and this is probably the one that's not talked about very much, is duplication of data. There's a lot of research that's out there in terms of the detriment of having duplicate data in LLM apps. I spent 8 years at a company called Riverbed doing WAN optimization and data deduplication. And there's a lot of duplicate data in the enterprise. If you think about Office 365 or Confluent, SharePoint, I'll share a document with somebody, they'll change it, share it with somebody else, multiple versions floating around. When you look at that data from a chunk level, which is what we end up doing in vector databases with the help of, was Unstructured, Dinesh, was the company? Unstructured, yes. You run into a lot of duplicate chunks across these different documents. So one of the key issues, though, with duplication of data when you're building a vector database is just the amount of it. If you think about a chunk of data that somebody has access to in one document and doesn't have access to in another document, how do you deal with that, right? And across the enterprise use cases that I saw back at Riverbed, we would see routinely 90 to 95% of the data we could remove because it was data we'd already seen before. So this is really a key issue, right? If you try to just copy permissions directly from a document and put them as metadata into your vector database, The next time you see that same chunk of data in another document, you'll overwrite the metadata and you'll have a different set of permissions. So being able to resolve those permissions on a per chunk basis ends up being critically important here. And I promise I didn't steal from Dinesh's presentation, but I am using Apple 10Q statements. But it's a great example, actually. If you look at them, just the amount of common boilerplate you'll see across different 10Qs. The differences are very nuanced. They're difficult to predict. If you were to ask an AI to say which one of these is 2023 and which one is 2024, there really isn't the information there to be able to infer that, unless you're able to look down at the headers and footers of the PDF, and there's a rule that you could use to extract that as metadata associated with it. The classification is going to help you. Pattern matching and regex isn't going to help you distinguish these two either. So how do we do it? Well, we've got to be able to identify data at a very fine-grained level. And by identify, I mean understand exactly where did it come from. Because if we can build the graph of the different sources that these chunks of data appear in, we can then algorithmically or analyze what the permissions are and determine by either prevalence or precedence or some policy what the permissions on that chunk should be, not just whether it's what it is in that document at the moment. So that's summing up about a 4-year journey building a solution that does just that. What Caber is able to do is to look at all of the documents that are ingested into a vector database. We build an index on the side to graph the relationships of chunks to the different sources that they come from, the APIs that move them, the users that are accessing them and such, to be able to understand at a very detailed level what the lineage of each of these chunks is. And then like I said, by understanding that lineage, we were able to assign the permissions deterministically to each of those chunks. So just looking at about 6 or 7 different 10Q statements, this is a graph of what we see after chunking these different documents. There's a lot of common data chunks, which are the red dots at the top. The purple dots in the middle aren't really all that important. And you can see the different 10Q statements that these chunks come from. And there's a lot of commonality. So we're able to look at that and determine, based upon a policy, where each of these chunks should derive its authorization information, its permissions from. And then we can use that to be able to look at the data that's being retrieved out of a vector database and determine whether or not the user that data is destined for is authorized to access that data at the chunk level. So I'm going to switch here to a demo, which should be pretty quick. So the top is user Amy. And Amy's the Apple CFO. And she has access to released and unreleased financial statements for Apple. The 2023s we consider released, and the 2024s are unreleased. So she asked the question, how's Apple's gross margin percentage evolved from Q1 2023 to Q3 2024? And so I built this on top of the RAG demo that Bazilla's folks have so kindly provided. Thank you very much. Appreciate that. We're agnostic to the vector databases. We're agnostic to the LLMs as well. And we're just dealing with some slow Wi-Fi here. Running. Fingers crossed. Wow. Okay. So what we see is, I'll just scroll this down. So she gets a pretty complete answer. Apple's gross margin percentage is a notable increase between Q1 23, 2024. It's pulling in data from Q3 2024. And we can see here on the side is the actual data that was retrieved out of the RAG. And pretty complete set of data to answer the question. If we switch over to Bob, who doesn't have access to the 2024 data, we'll ask basically the same question. Tell me how has Apple's gross margin percentage evolved from fiscal Q1 2023 to Q3 2024? And we'll see if this goes a little bit faster. So Bob, again, doesn't have access to the 2024 data, but all of it is stored without any permissions inside of the vector database. We've integrated into this application through an SDK. And so we're filtering the data that's coming out of the RAG before it goes to the LLM. So it ends up being a relatively nice experience as far as what the user sees. We've redacted basically all the data from the 2024 statements. But he still gets a good answer. The context provided does not include specific gross margin percentage from 2023 to 2024. However, and it goes on to give a relatively complete answer. And that is despite the fact that we've redacted quite a lot of data coming out of the RAG. And we're doing this at a level that's smaller than the chunk size that you would use to build the RAG with. So this RAG is built with 1,000 byte chunks, and we're redacting at about an average of 128 bytes. So we're going to see more duplication of data at that level than you would at the 1,000 byte level. But nevertheless, it's very effective at being able to recognize where did this data come from, attribute it to those 2024 statements, and then redact it so that this user isn't accessing any of the data that they shouldn't be. So like I said before, we're integrating with an SDK. We have a number of different identity connectors to be able to get the user authentication information, their groups, et cetera. We also have a number of connectors to be able to basically in parallel build our own index of these chunks, put the permissions on them as the vector database is being built or updated. One of the interesting things that we need to do, if you think back to what I was mentioning, that it's not the user, it's the agents that are making these requests, is we need to be able to track what I'll call the on behalf of connections. So the connections that the clients or the agents are making on behalf of those users. And to do that, we're basically tracking the data that we're seeing in the API requests and responses across these different connections that are being made. And in this case, it's a relatively simple bounce diagram, if you will. But the green is the data that exists in the prompt that the user entered. The agent then uses that to look up data in the vector database. The response comes back, and we're able to track the data across these different connections, across these different requests and responses, to be able to attribute them all to the user Bob. And in that way, we can say, oh, these connections, like this connection between the agent and the RAG, we know it's made on behalf of Bob, so we can redact the data at that point rather than having to wait until it's actually traversing the path back to Bob. And of course, that's the way that we can give such a seamless experience in terms of the what the user sees. But actually, the ability to do this kind of byte sequence level tracing of data across applications opens up actually quite a lot of interesting capabilities that we can bring to bear. Access control is just the start, because if you're thinking about security in an enterprise, you're mostly concerned about what happens. Well, if you're not a development engineer, if you're a security engineer or one of the security team, you're mostly thinking about what happens when something goes wrong. What happens when I'm attacked? And when things go wrong, this ability to be able to trace the movement of these byte sequences through the different services, different objects that these chunks appear in, allows us to provide significant accountability and auditability, basically a full trail of how did that data move in any given incident. So for example, if somebody does get access to data that they shouldn't, or if, say, you're using a agentic AI where you have autonomous actions that are being performed by an LLM on behalf of users, and those actions are unpredictable, things can go wrong in ways that, of course, you are not able to predict. And so when they do, you want to be able to find out exactly how did that happen. This is an example of a different demo that we've put together, which is basically tracing data flow from a user that's uploaded that data to the point where an agent has grabbed the data, modified it, and returned it in a response to user Bob. And then every API call that was involved in that transaction is recorded, and we can provide that as an audit trail. And then, of course, when you get deeper into these applications that become more and more complex, being able to understand and have observability in terms of the actual data flow that's happening within those applications becomes very important. And for this, we can provide some very high-level observability characteristics around whose data moved where, when, and what services touched it. But it also gives us the ability to start modeling if you think of black box modeling, it gives us the ability to model what the application is actually doing. And then this is where our own use of AI gets pretty interesting. We're able to then take that knowledge of how data moves within the application and feed it back to an LLM to find where there may be some security issues, some vulnerabilities, some places where there may be policies that are in effect that need to be modified to meet certain objectives. And so this is actually where, if we look at the complete set of capabilities from access control to auditability to remediation and analysis, we need to have all of those things put together. And that's what we're doing with Caber. So it's pretty new. It's pretty early days for us. And we're looking for folks who have a need to try it out. And we'd love to work with you if this is of interest. So thank you.